I got to know from Google that this is called a thermistor. Thermistor. Currently, I'm trying to somehow measure the capacitance of the capacitors that I have with my multimeter, regular multimeter without a capacitance reader. Trying to figure out. So I'm going with these two capacitors. This, if you could see, says 1 microfarads right over there. And this ceramic capacitor. Here it says this also that this is a 0.0501 microfarad capacitor. Because for this circuit I need two capacitors, one of 10 nanofarads, that's about 0.01, that's exactly 0.01 microfarads, pardon me, and 100 nanofarads, that's about 0.1 microfarads. But I don't have a 0.1 microfarad capacitor, so I'm going with this 1 microfarad, that's about 100, sorry, 1000 nanofarads.
I'll try to make sense of the circuit later on, but for now what I've done is I've, the yellow wire is the ground wire, which is this one right over there to the ground, and I've connected, so the red wire right here is the junction between the trigger and the threshold, which is this one trigger, threshold and trigger. And so a loop starts from the threshold itself, that is there, and ends at there, which comprises of our the potentiometer. So a loop starts from here, the right diode, the orange wire goes to the potentiometer, comes, the black one comes from here, the loop ends there. And the other two capacitors, the 1 nanofarad, the orange one, is this one right over here, which is on the control fifth pin, the last pin, and that is correct. And this one is a polarized, this one is a polarized capacitor. It starts from the junction again and goes to ground. So now I have not connected the ground of these two, which is common, the orange capacitor and the blue capacitor, the common ground, not connected it. So I've almost completed the circuit, the whole circuit. This one is coming out from the out, so I'm supposing it's giving out a, well, I'm confused. So here the out is supposed to be giving negative voltage, but in here he is connecting an LED later on to the ground and to the out. I'll try to figure this out, and also I think he's left the transistor part, the MOSFET part aside for now. So I think I finally have all the pieces together. So starting with the wires connected in series with the green wire, that is the positive 12 volts, or positive anywhere between 5 and 15 volts, that is this part. Starting from there, the white wire is going into the reset directly, as is here, and it's also going to the VCC via this red this red cable, this red cable right over here. Yeah, and then there's also a resistor right here which goes in series to the discharge via this green wire, as is here. So I made this to work somehow in the very first go. So you see if I increase the potential, I don't know if I'm increasing or decreasing the resistance here, but if I change the signal that I'm giving to probably the threshold of the timer chip, it's changing the LED's brightness. So I'm again taking, instead of a battery, I'm taking the 12 volt, the ground from the Arduino, and it's going through the Atmega. Atmega is taking the threshold value from the potentiometer, the rectifiers, pardon me, the diodes are just there to make sure that the inside the loop too, that is the loop here, the current flows only in one direction. So this rectifies the clockwise or the anti-clockwise of the potentiometer. And I'm still not sure, I'm confused why the capacitors are there. Probably got to do with the square wave generation. The out is basically giving the square wave, it's taking the threshold. So I'm not entirely sure of what this it is doing. Just that in a black box, I have my potentiometer right here, I have my LED here, and my source here. So if I were to only concern myself with these three things, the black box, that is my hand, is somehow reading the analog value and getting from the source only that much power on and off that is required for the LED. Very happy that this worked. Now I can move on to the next tutorial. I'll come back later on someday to understand the T255 timer chip. And also, you can verify that this is indeed a PWM by the flickering that you see in the camera. I cannot see that, but the camera can capture that because the refresh rate of the flutter, the flutter speed is quite high, the flutter frequency. So you can see those on and off, while I, as a human, cannot see 60 Hz. So this is indeed a PWM, and not just a regular potentiometer control, where most of the power is dissipated through heat to the potentiometer. One final blooper. I don't think it's working with the 3.3 volt. I changed it from 5 volt to 3.3 volt. And it's not working even if I try to move it all the way out. That's probably got to do with the Atmega. It takes only 5 volt or greater, I think. to read the docs. So I'll come to it later on sometime.
One last thing. I wanted to measure the out voltage and see its transition. But I'm sorry, I was having a panic moment after I removed all of it. And then I realized that I had to do that. But now I'm relaxed because anyway, the frequency of that would be more than 60 Hz, which I don't think this would be able to catch. Although I think the oscilloscope that we have in the lab here at Patya will be able to catch that. So that again, for some